Class, welcome to this physics tutorial. Today we are talking on probability distribution series. Under that, we are starting with the binomial distribution. Most students fail binomial distribution, but let me show you how to avoid this. In binomial distribution, we talk majorly of two events. Either you fail or you pass. This is binomial distribution to two events. It will occur or it will not occur. Let me give an example. When you toss the coin, when you toss a coin, either you get the head or get the tail. You cannot get anything other than the head and the tail. Or when you write an exam, either you pass or you fail. So that's what my normal distribution is about. Only one by. It means two. So it's talking about only two events. And we have the different properties of binomial distribution. Let me discuss them here. Properties of binomial distribution, we have parameters of binomial distribution. We have three major parameters of binomial distribution. We have our n, this stands for sample size. We have our P, which stands for success, and our Q, which stands for failure. And if you can go my focus video on probability, I say probability of an event occurring is 1. So we can say our success plus our failure equals to 1. So we P, which stands for success, plus failure equals to 1. You can play with this kind of like, I can also say B equals to 1 minus Q, or you can say Q equals to 1 minus Q. These are the parameters of binomial distribution. The N is sample size, the P is success, and the Q is failure. Now let's talk about the properties of binomial distribution. One of the properties of binomial distribution, we have the mean. The mean is the first property of binomial distribution. And the formula for the mean is sample size times your success. NB. That's the formula for the mean. We have your variance. And the formula for the variance is NBQ. And finally, we have our standard deviation, S, which is square root of NBQ. These are the properties of binomial distribution. Now, the general formula for binomial distribution. This is the general formula for binomial distribution. General formula. General formula was P of X equals to R equals to combination of N R times P R times Q N minus R, which is the general formula for binomial distribution. Whatever problem they give you, is this formula you use to solve them. You understand better when I start solving problem. So let's solve for examples to get more knowledge of binomial distribution. So we have a working example here. The example says probability that the cancer patient survives when injected with a newly discovered drug is 0.75. Find the probability that exactly 8 out of 10 cancer patients survives on being injected with a new drug. All my videos, before you solve any problem, you assign your parameters. So let's put it together. Give it. What do we have? We have that. See the probability that the patient survives, meaning success, P equals to 0.75. Find the probability that exactly 8 out of 10. Out of 10 means the sample size. So N equals to 10. And X, what's a equal? Equals to 8. Or let's call it R, also using my institution. So R equals to 8. Survive when you take the main blows. We have our P, we have our N, we have our R. What's our general formula for binomial distribution? P X equals to R equals to U. Combination of N I minus P of this for R times Q this for N minus R. This is the general formula for binomial distribution. We have our N, nice, we have our R, we have our P, but we have our Q. But we can find our Q is because Q equals to 1 minus 1, which is equal to 1 minus 0.75. The point is to get 0.25. But now, let's put this now, come over. So now, x equals to what is 8, because our r is 8, equals to n 10 combination r, which is what 8 times b raised to power 8 times q raised to power n minus r, which is 10 minus 8. So 10 minus 8. So p x equals to 8 equals to 10 combination 8. Either you find the calculator, or if you have a calculator, can use this formula. Formula states, let me write this out here, so you can use formula. Equals to n factorial over n minus r factorial r factorial. If you have a calculator, you can use the formula to get to n, your 10 combination 8. Where 10 is your n and 8 is your r. Whatever your calculator, you can easily punch it here directly. So let's punch it directly. You can say 10 combination 8 45 times p is what? 0.75. Let's do this in fraction. 0.75 in fraction is 3 over 4 h power 8 times q is what? 1 over 4 this power 2. Let's point this. For this, I'm going to answer what we want. We get 0.282. So this is the parameter that exactly 8 out of 10 answer questions survive completely famous a new draw. Let's try the second example before we move to the next distribution series. Okay, so we have another example here. Now that says a factory will use light bulbs and the probability that a bulb is electric is 0.1. Equality inspector randomly selects 8 bulbs on the production line. What if I make that asking 3 bulbs are defective? So be the probability of defective bulbs. So let P be the probability of defective bulbs. So P is what? Say probability of defective bulbs is 0.1. So P is 0.1. And our Q is 1 minus P, which is 1 minus 0.1, which is 0.9. Equality inspector randomly selects 8 bulbs. So our sample size is 8. So N equals to 8. What's the probability that close 3 bulbs are defective? At most, meaning it should not be more than 3. 3 should be the maximum. So it's from 3 down. Meaning, we find probability of 0, the probability of 1, probability of 2, and probability of 3. That's what at most means. Meaning 3 should be the highest. So you can say probability of at most 3 bulbs means x should not be should be less than or equal to 3. This is the probability of at most 3 bulbs. It can be 3 and it can be less than 3, but it cannot be 4, 5, and 6. That was at almost 2 bulbs soon. So now let's continue our solving. So for me, I can say the general binomial distribution formula is what? P x equals to r equals to combination of n and r times p of r times q n minus r. This is what does this mean? So to do for probability of x is 0, where x is 1, where x is 2, where x is 3, and we'll add them together. So let's start. Probability of 1x equals to 0. This is the formula now. What's our a? It's our r is what? 0 times p. Our r is what? 0 times Q 80 minus 0, which is get 0. You get 0.430. This is your, which is when x equals to 0. We continue. Now, when x equal to 1, because we said this is probability of when x equals to 0 plus probability of when x equals to 1 plus probability of when x equals to plus probability of when x equals to 3. This is what at most 3 is. So I'm like this class. This 8 combination 1, I use 1 times probability of 1, sorry, q raised power 1 times q raised power n is what? 8 minus 1, which is 8 combination 1 times our p is what? 0.1. 0.1 in fraction is 1 over 10 raised to 1 times 9 over 10 raised to 7. The point is what we get 0.382. Go to the next one. Probability of 1x equals to 2. The same formula. 8 combination 2 times p of what? 2 times q 8 minus 2. Let's just move this one directly. We want the direction. What are we going to get? Get 0.149. And the last one, probability of 1x equals to 3. We have 8 combination 3 times p, 3 times q, 8 minus 3. We want this, what are we going to get? 6 times 0.03. So what do you say? Probability of x at most 3 means it should be less than or equal to 3 because 3 is the highest. Meaning adding probability of 0, 1, 2, and 3. So let's add to our core values. Whatever the final answer, where is it? Now probability now x less than or equal to 3 now equals to 0.430 plus 0.382 plus 0.149 plus 0.03. To add all this, you get 0.99. This is your final answer. This is the probability that at most 3 bulbs are defecting. Now let's go back to the next distribution series, which is the Poisson distribution.